Alright, hi Year 11s, this is Mr. Lim here, and this is our 7th video in the calculation series about percentage composition, so let's get started. Alright, so we're going to be working out the percentage composition of substances, and we'll find out what that means. Let's have a look. Alright, so the chemical formula of a substance identifies the ratio of atoms and elements in a compound. So if you think about something like H2O, that means that there's 2 hydrogens, and 1 oxygen. And so we knew that already, as that's the ratio of hydrogens to oxygens. Okay, so using the mass of each element, okay, the ratio of atoms to element can then be used to determine the composition of the substance by the masses of each component. So what does that mean? Okay, so we know that 2 hydrogens is going to be 2 times 1.008 grams per mole. All right, so remember that each of these atoms weighs a different amount. Okay, so the hydrogens are really small, so they're only going to weigh a little bit, whereas the oxygens are going to weigh much more. They're going to be 1 atom of 16 grams per mole, or 16 AMUs, and so therefore it's going to be a much larger component of the molecule. All right. So therefore, the idea is that this information can be useful for identifying compounds or determining the compounds with the most of a desired element by mass. All right, so this is kind of just using the ratios to work out how much of different elements there are in a particular thing. All right, so if we were to look at the water again, right, those relative atomic masses would equal to 18.016, and out of that 18.016, 2.106 of it is hydrogen and 16.00 of it is oxygen, all right, which translates to something like 11.19%, okay, of hydrogen, and the remainder 88.81% oxygen, all right. So later on, we'll learn how to use that percentage to work out, what we've done here is we've gone from the ratio and we've worked out the percentage. Later on, we'll learn how to go from the percentage back to the ratio, especially if that ratio is unknown, right? So those are the two kind of steps, but we're going with the process of knowing the formula and getting to the percentage now, right? And that's where we're starting at. All right, so for example, if we are looking at iron 2 chloride versus iron 3 chloride, okay, so iron 2 chloride is 44% iron and iron 3 chloride is only 34% iron. So if you want to pick out the one that has more iron in it, then it would be iron 2 chloride. All right, so all we're working at is how much of a percentage each element there is in a particular substance. All right, so to work out the percentage composition, it's calculated by the percentage of each element is equal to the RAM of all atoms of that element over the RAM of all atoms. Okay, so what does that mean? Let's have a look at some of these calculations here. So determine the percentage composition over here, the percentage composition of all of those things there. So let's go walk through some. Okay, so let's do the hydrogen in the sulfuric acid. So first of all, we would need to work out the molar mass of the RAM of all the atoms. So we have to work out the molar mass of the H2SO4, which will be equal to 2 times 1.008 in brackets plus 1 times 32.06 and 4 times 16.00. Okay, so that's just what we've done before. Okay, and it turns out to be 98.076 grams per mole, and we know that already. Okay, so that's just the RAM of all atoms. Okay, now then we have to work out the molar mass of all the hydrogen bits in it, because we were asked for hydrogen in that H2SO4. So all of the bits of hydrogen, which would be 2 times 1.008, which is just equal to 2.016 grams per mole. All right, and so therefore we can work out that if we wanted to, the percentage of hydrogen, and notice how I've changed that from being a H2 to just the H, because what I'm doing is that this one here was for all of the hydrogens in it. Okay, so that's how we work out all of it. But this now is just we want the percentage of hydrogen within the compound. All right, and it'll be equal to 2.016 over 98.076 times 100, which will be equal to 2.06%. Okay, so that's how you would do it. Fairly straightforward. Find out the part, find out the total, work out the percentage. Okay, right, let's have a look at the next one, which is the lithium, and we'll do that in a different color, lithium in lithium carbonate. Okay, so it's kind of be useful to know what the formula for lithium carbonate is by memorizing all of your ions. All right, but in theory, you should be able to work out the relative atomic mass of this as 73.892 grams per mole. We would then say, okay, what's the molar mass of the lithium component of that, which is 2 of the Li's, which would be 2 times 6.941, which would be equal to 13.882 grams per mole. Right, and then we can work out the percentage of that lithium within it as the 13.882 over the 73.892 times 100, which will be equal to 18.79%. Okay, so that's nice and easy, just getting the percentage of the different parts. Okay, and so if we look at the next two questions, here's how you might work out those next two questions. Okay, it's really kind of important to remember that it's very important to know how to take these names and turn them into compounds or formulas, because that's not always going to be given to you. Okay, let's have a look at the next part. All right, here what we're doing is we are comparing how much of these different compounds, how much they hold the, what percentage of each of these compounds is the metal that you're desiring, which happens to be the metal, which is the lithium or the copper in these two examples. Okay, so the lithium here, we would just do all of those things again, but we would do it a couple of times. Okay, so if you want to just, I'm not going to go through this because that one's nice and easy, but the percentage of lithium in lithium nitrate. Okay, so I'll just provide you the answers is 10.07%. Okay, so you can go do that calculation and check it against this one here. The number of the percentage of lithium in lithium carbonate, which we actually did before, which is equal to 18.77%, and the percentage of lithium in lithium hydroxide is equal to 28.98%. Okay, so you can follow that same process that we did before to work out those percentages, check that you got that right. And if you want some worked examples, here's the copper ones. All right, so there are some worked examples, or at least a few more steps in there as well. Okay, so that's that, and we'll see how you go. Pretty straightforward calculation. Adios.